Hello, Math 1 students. This lesson is going to be on 7.c, which is I can evaluate a function using function notation. Now, first, what is function notation? And function notation is basically an easy way for mathematicians to name and represent a function, right? So when we look at this, right, function notation is basically the name of a function, right? And then in parentheses, they use the input, and that would all equal the output or the function, right, in a way. So this is basically your function, or which ends up being your output. So when we look at this, right, when we see something like this, right, we would read this as f of x, meaning the name of the function, right? So in f of x, f is the name of the function, and x is the input of the function, okay? And that's really, 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 really important to know and understand. Now, even more important is to know that when we see y and f of x, right, or function notation mean the same thing. So when we have ordered pairs x comma y, right, it's really no different than x comma f of x, like such, okay? Now, when we go to evaluate a function, right, the first thing you're going to do is identify the input. And once you identify the input, right, you're going to substitute the input for each independent variable, okay? And I'm going to say independent variable instead of x, right? Primarily, it will be x, right? But that can always change, right, based on what the function notation. So once we identify the input, right, everywhere we see that, variable in the function, we substitute the input in for it. And then we evaluate the expression. Okay, so with this in mind, right, let's take a look at these. So here I have, this is given the function f of x equals negative 10x plus 8, evaluate the following. So right away, the name of the function is f, right? So the name of the function is f, and the input is x. So right away, just to make things easier, when I do f of a, that means everywhere I see an x, I'm going to kick it out and replace it with an a. So f of a would equal negative 10 times a plus 8, and if I simplify that, it would just be negative 10a plus 8, right? So what we're trying to show you here is all you're doing is replacing the variable with the input value in this, parenthesis. Next, f of 3, right? So f of 3 would be negative 10 times 3 plus 8. Now I want to evaluate this using correct order of operations. So right away, that would be negative 10 times 3 is negative 30. Negative 30 plus 8 is going to give me negative 22. So f of 3 is negative 22. And if I wanted to write an ordered pair out of this, it would be 3, negative 22. Next, f of negative 2, right? So now everywhere I see an x, I'm going to replace it with, right, a negative 2. So negative 10 times negative 2 plus 8 would give me negative 10 times negative 2 is 20 plus 8 would be 28. So f of negative 2 is 28. Now the last one here is a little tricky. F of negative 4, or x minus 4. That means everywhere I see an x, I'm going to kick it out and replace it with x minus 4. So it's going to be negative 10 times x minus 4 plus 8. And now I have to simplify this. Distribute the negative 10. That's negative 10x. Negative 10 times negative 4 is plus 40 plus 8. Right away when I combine like terms, negative 10x plus 48. So that's what you would get for f of x minus 4. Okay, so understanding what we're inputting and how to evaluate the expressions is critical. All right, as we move along. So now we're given three functions, and this is kind of the example that I like to use to show why we use function notation. Is if I look, each of these has a different name. It's function f, function g, and function h. Okay, so the first one, they want us to evaluate g of 3. Well, if I look at the name, right, g of 3 tells me I'm going to use this function. So everywhere in that function, right, g, everywhere I see an x, I'm going to replace it with 3. So g of 3 would equal negative 4 times, replace that x with 3, plus 2 minus 8. Now, order of operations tells me to do what's in the parentheses first. So negative 4 times 5 minus 8 would give me negative 20 minus 8, which is negative 28. If you have trouble evaluating these guys, if you have a graphing calculator, all you have to do is plug it in exactly the way you see it right after your substitution. So if I take this and plug it in exactly the way I see it, negative 4, open parentheses, 3 plus 2, close parentheses, minus 8, hit enter. Right away, it evaluates it correctly for me. Okay? So when I go to do the next one, f of negative 5. So since we're using function f, I know I'm going to use this function, right? So f of negative 5 equals, everywhere I see an x, so 6 times x would be negative 5 plus 2. That's going to give me negative 30 plus 2, which is negative 28. Now, h of 5, right? Because I'm using function h, right? I know I'm going to use this function here. And everywhere I see an x there, I'm going to kick it out and replace it with a 5. So, h of 5 equals, in parentheses, 5 squared plus 2 times 5 plus 1. That's another thing I want to, let you know is anytime we do these, we want to, substitute using parentheses. Now, this is one that's probably going to benefit you to use the calculator, right? So I plug it in exactly the way I see it on my paper. Open parentheses, 5, right, to the second power, right, arrow to the right to get out of it, plus 2 times 5, right, or I can do, let me do it the way I told you guys. So 2, open parentheses, 5, close parentheses, and then plus 1, hit enter, and h of 5 would be 36. All right, and now I have one more here. G of negative 8 tells me I'm going to use the purple function, right? So g of negative 8 would be negative 4 times negative 8 plus 2, all minus 8. Should be negative 4 times negative 8 plus 2 is negative 6, minus 8. Give me 24 minus 8, which is going to be 16. So g of negative 8 is 16. Okay, so evaluating functions, do not make that harder than it needs to be. All right, now, we can represent functions in tables just as well as we can, using expressions. So how do we evaluate these, when they're in a table? Okay, so r of negative 3. So when we look, right, you have function f, you have function r, and you have function t, right? All of these at the top are your input values, okay? Then all of these other elements are going to be your output values. So when I go to evaluate r of negative 3, I know right away, right, r of negative 3 tells me I'm going to use this blue function, and I'm going to go across to when x is negative 3, right? So if I look, x is negative 3. When I go down, what is the value of function r? That would be negative 35. F of 0, right? So now I know I'm going to go to the yellow function. I'm going to go to an input value of 0, right? And then as I scroll along, function f has an output value of 3 when x is 0. T of negative 3, right? So if I look, all right, function t is here. I'm going to go all the way over to an input of negative 3, and right away I get negative 4.24. R of negative 2, right? I know I'm going to go to this blue function, right? I'm going to scroll all the way over to an input value of negative 2. When I come down, what does that end up being? Negative 16. So this is all about how to read a table, basically. Okay? Now, taking it a step further, here, they're telling me my output, right, r of x is negative 9. So what input value has an output value of negative 9 for function r? So what I'm going to do is I'm going to go to function r, and I'm going to look for an output value, right, of negative 9, which is right here. And then right away, if I look up, what input gave me that output? That means x is negative 1. Okay, if I do it for the next one, if f of x is equal to negative 1, right? So right away, function f, where is the output, right? Negative 1. Well, here's an output of negative 1 for function f, right? What input gave you that output? X was negative 4. So it's just reading the table a little backwards. Now, letter G, f of negative 2 plus r of 1. So f of negative 2 right here. Then you have r of 1. So f of negative 2 has a value of negative 3, doesn't it? So negative 3 plus r of 1. So I go to r, go to an input of x is 1. That's negative 7. And negative 3 plus negative 7 is negative 10. Okay. Then r of 3. So if I go to function r over to 3, r of 3 gives me 19 minus f of negative 5. So here's function f. Input of negative 5 gives me an output of 3. And 19 minus 3 is 16. So using a table should be pretty straightforward. Okay. Now, the last one we're going to do is using the graph. Okay. So here you're given function g of x. So they want you to find g of 8. So what we're going to do is we're going to go to x. So they're basically telling me x is 8. So when I go to the x value of 8 and I go to the graph, what is the output y value? Well, that ordered pair would be 8, 0. So my output is 0. Now when I do g of 4, right? I go to 4 on the x-axis, which is right here. And I'm going to go up to the graph, and I'm going to identify when x is 4, what's my output y? That would be 8. So g of 4 would just be 8. g of negative 2, right? If I go to negative 2 on the x-axis, and I go down to the graph, it's right about here. What is the output if x is negative 2, right? What was y? That would be negative 10. So that would be negative 10. Okay, so using the graph should be pretty straightforward. Again, if you know how to gather the ordered pairs, should be good to go. Letter D, if g of x is equal to 6, then x is equal to. Now they're telling me if y is equal to 6, then x is equal to what? So if I go to 6 on the x-axis, right, and I go over to the graph, there are 2 points on this graph that have an output of 6. If I write this ordered pair, that's 2, 6, and this ordered pair would be 6, 6. So right away, I know this x value and this x value give you an output of 6. So right away, if g of x equals 6, then we know x is 2 and 6. And letter E, g of 1. If I go to 1 on the x-axis, and then I go up to the graph, right? It's not exact, so let's just say it's about 3.5 plus g of 6, right? We know is going to be 6, and then 3.5 plus 6 would be about 9.5. So knowing how to use the inputs and outputs, right, are by far the most important things for these type of problems. Go ahead, do the student practice, and let us know if you have questions.